Alright, so we have read the question, we understand it, so now it's time to figure out how to do it. Let's grab this page. So, I would usually start off a question by writing what we're given. It's a pretty sure way to go, you can't really miss anything that way. So, we know that we're given the mass of one cart, so M of C1 is 1 kilogram. And while that not may seem extraordinarily important, it actually will be in the long run. Make a note of that. We also know that the setup causes an overall acceleration to experience 2 meters per second squared acceleration. What did I say? We also know that the acceleration that the cart experiences is 2 meters per second squared to the right. So we will make a note of that also, that the A of cart C1 is 2 meters per second squared. And we'll make a note of it that it's going to the right when we draw our FBD further on. And the block is 2 meters per second squared going down. Again, the acceleration of the block is 2 meters per second going down. Again, we'll make a note of that when we make our FBDs later. So, I mentioned FBDs, we're going to go ahead and make them right now, just to make sure we understand what's going on, which is very important in this type of question. So, with regards to the carts, this is our cart right here. And we're told that it's traveling frictionless, which means we don't have to draw any arrows going the opposite direction, but rather that it has an FA going in the positive direction. But in this case, it's not an FA whatsoever. We know that it's attached to a string, so we're going to say this is FT. Now, unfortunately for us, we do not know what the FT is as of yet, but we will find that soon enough. Actually, in reality, I don't think we need to find out what it is. So, one moment. Sorry. I'm going to drop here. So, we're not going to define FT at any point during this diagram. Looking at an FBD now for the block, this one's a bit different. This one we're going to be looking at in the y-axis, so we can go ahead and draw an FBD for this. This is the cart. This is the block. Now, it's quite easy to know what's acting on the block. We always have it in FG. FG. And we're going to assume that this is the positive FG. Just as a rule of thumb, it's important to make a note that whichever way the object is moving, that's generally where you want to make it positive. And remembering from this, we also have an FT. Now, looking at these two FBDs, we can actually derive two equations from these FBDs. But first of all, we're going to look at this equation, this FBD up here, right at the top. The cart experiences only a force of tension due to the fact that there is no force of friction acting on it. So for that reason, we can go ahead and make a formula for that FBD. So, cart, we can go F net. And this F net formula is definitely the principle of this entire section. In reality, I don't even think there is too much else you have to know, just how to properly use it and properly manipulate it when need be. Now, just take a pause. Looking at this, we know both M and A. And remember, this is for the cart. So, while we don't know what exactly the FT will equal permanently, we can, however, say that the FT equals MA, which, as we know from our given, the mass of the cart 1 is 1 kilogram. So we can go ahead and write 1 kilogram here, plugging it in for M, sorry. And we also know the acceleration of the cart, but we'll also assume it's for the system, which is 2 meters per second squared. And common math, 1 times 2 is 2, and our units turn this calculation into newtons. Now, generally speaking, we don't really have to find that, but that's not really important. That's not what we're looking for. We just completed the equation. We're more so interested in this. That's what we're interested in at this moment. Because now we can actually formulate some sort of equation for our second block. Now, excuse me. So we can go ahead and make an FVD now, or I'm sorry, not an FVD, an equation now for the block. And we can do so by specifying that, okay, this is going to be for the block. Now, what we can look at now is that we can kind of assume at what the formula for the block will be. Again, we're going to be working with F net equals MA, but we don't really have too many of those variables. But as we will soon see, we do have what we need to solve for the mass of the cart. So go ahead and write in our formula once again. F net equals MA. Don't forget to write your icons, whatever you want to call them, over your arrows over those, just so we don't lose marks. And looking at the FBD for the block, we can see that we have, for the FNet, an FG and an FT. Now, earlier I'd stated that whichever way the object is moving, that's where you want to put your positive. That's what we're going to do. We're going to put down as being positive and up as being negative. Just because it's going to be a lot easier to work with and it's more of the common rule of thumb. So, looking at this, we have a positive FG for this FNet, so FG and minus FT for the force of tension equaling MA. Now, this may not look like much, but we're going to use a common math principle, the process of substitution, because we do have a formula for FT. Now, in reality, we could really just plug in the 2, but it's just better to do this this way, just so we can see where that 2 comes from in terms of this equation. So, on that note, we also know what FG is, when you think about it. FG is simply mg minus ft, which is ma, equals ma. Sorry about all that noise. Now, here we have our equation where we can start substituting in our variables. And again, as a rule of thumb, I think it's a lot easier to rearrange your equation until you are completely ready to plug in your variables. That just saves down a lot of trouble and any mistakes that could occur while you're doing so. Now, we do not have the mass, obviously. This is the mass, and I'll make a note of that. This is the mass of the cart. The little c will represent carts, with B representing, mg block. Sorry about that. So this will represent mg block, and this will be the C, and finally B. We could use A or B, or C or B for the acceleration, but because of the fact that in this case it's going to be for the system, it doesn't really matter, but we'll go ahead and put a B just in case. Make that A look a little nicer. So, believe it or not, from this equation we can derive the mass of the second block. And we can do so by simply just plugging everything in now. So, we don't know mass, but we do know gravity. Gravity is 9.8 m. And don't plug in units, there's no point. We know that it's supposed to be a mass, so we can just leave it without, because we know it's going to be kilograms at the end. So 9.8 m minus ma, okay? And we do know both of these. we know that m is 1 of the block, and we're just looking here or here, it doesn't really matter, and that the acceleration is 2 equals, again, 9.8 and m. Or sorry, what am I doing? 9.8. Oops. My mistake. 2m. Perfect. So just go ahead and solve that now. 9.8 meters, 9.8 m, excuse me, minus 2 equals 2m. Now, at this point, it's just a common solve for your missing variable. What's it called? Algebra, I guess. We can go ahead and move the 2 over, so that's going to be, not 2, what am I saying? Yes. So, just looking at this question now, just to make sure we're doing this right, 9.8 So, what we're going to do now is we're going to move both 2's over, so that it is going to be, we're going to move this 2 over here, so it's going to become positive 2, and we are going to move this 2 over the other side, so that's going to be 9.8m minus 2m. Now that we have common variables, we can go and subtract them. So 9.8 minus 2, that's 7.8. 7.8m equals 2. Go ahead and divide by 7.8 on both sides now. Which gives us m equals, we divide by 7.8. I wish I had a calculator with me right now. There's one. So 2 divided by 7.8 is 0.26, which, good for us, is the correct answer. You guys can't see that. M equals 0.26 kilograms. And I'll make a note that that's for the block. MB. So that's how you do question 1 on page 3 of the review sheet. Just simply figuring out what you need to find, writing it all down, and then looking if you can substitute anything in. So key points to do this question, I would say, for all of them, write down what you're given. That's going to make it a lot easier. You're going to have all your information in front of you. Next, make FBDs. Again, it's going to make everything a lot easier for you. It also gives you a visual representation of what you actually need to plug into the F net equals ma formula, Newton's second law. And just from using these FBDs, we derived 2 formulas, F net equals ma, Ft equals ma, which we then substituted into another F net equals ma formula to give us the formula and eventually the answer of the mass of the block. So, thanks for watching. That's how you do question 1, again, on page 3, part 2.